This is the fifth video on logarithms and exponentials and looks at domain and range. Now, viewers are reminded that these videos are really aimed at people who are just leaving school or entering university, and mostly they're aimed at engineering undergraduates. So far, we've focused on the definition and algebra for exponentials and logarithms. This particular video is now going to look at the domain and range of these two functions. So some background, just to make sure you're up to date. A logarithm, and here's the key word, is defined as the inverse function for an exponential. So, as we know that an exponential, that is y equals e to x, is a one-to-one function, that is, for every x there is a unique y, and vice versa, then consequently, because logarithm is the inverse function, it must also be one-to-one and unique. Now, the sort of expressions we might use for an inverse function, if we had y equals f of x, the inverse function could be written as x equals f to the minus 1 of y. But here, we've got y equals e to the x, there's the exponential, and x equals log ey. That's writing it down as the inverse function, but using the variables in the same corresponding positions. So domain and range. Now, these are things that you'll know from the earlier videos. An exponential always gives a positive output for any input argument. So there's your exponential, y equals e to the x, and what we're saying is e to the x is positive for all real x. And therefore, this is what we get. The domain is minus infinity, less than x, less than infinity, but the range is naught, less than y, less than infinity. Now, because the logarithm is the inverse function of exponential, then it means the range and the domain have to swap. So what was the domain of exponential becomes the range of log, and what was the range of exponential becomes the domain of log, because in essence we've swapped the positions of the x and the y. So if we write x equals log ey, then what we're going to get is the domain is naught, less than y, less than infinity, and the range is minus infinity, less than x, less than infinity. And what you'll notice, hopefully it's clear, is the variable that was the domain for the exponential becomes the range for the log, and the variable that was the range for the exponential becomes the domain for the log. So you'll see we're consistent there. So here's some graphs so you can see what's going on. We'll start with the exponential. The domain, minus infinity, less than x, less than infinity. So you can see here's the x-axis along the bottom, and here's the y-axis, or the e to the x-axis up here. So you see the domain, all values of x, and the range, positive values only. So if I, for example, make this axis, I meant that to be black, a bit darker, what you'll see is exponential is always above the axis there. What about log? Well, for log, we're swapping the domain and the range. So in this particular case, for the log, the domain is only going to be the positive values. So you can see there, naught, less than x, less than infinity, but the range now goes over the full scale. So their inverse functions one of another, so the domain and the range swap. And hopefully it's clear when you look at those two graphs that that is what has happened. If you look at corresponding values, you can see here it's not surprising what's going on. So if I look at the exponential, there was a coordinate there, 0, 1. The corresponding point in the log is clearly 1, 0, because I've swapped the two variables. And I could do the same at a higher point here, and you can see here we've got a point something like 1, 2.5, whereas down here it would be 2.5, 1. And a final thing to emphasize here, it's quite important, is log is not defined for negative numbers. If you write log of minus 1, it has no meaning if you're talking about real numbers only. So some conclusions. For real numbers, You cannot take the logarithm of a negative number. The domain is restricted, so logarithm is defined only for positive numbers. Similarly, the range of the exponential is only positive. It's not possible for e to the x to give a negative result if you've got real numbers. And just to summarize again, logarithm and exponential are inverse functions one of another, so the domain and the range swap.